Okay, let me give you a quick run through of different plasma description. There's a microscopic, which basically means a single particle motion that will be summed over in a way. So single particle can be think as basically the second law of Newtonian mechanics, just mndv dt equals to qe plus q over c cross b, and of course the velocity is defined by dx dt. Sorry, and this is the original theory is based on the Liouville equation. And if you sum all the particles together, of course, a particle can be thinking as a delta function in terms of location and velocity or momentum. So if we sum all of them together, we will end up left with a distribution function in terms of position, velocity, and time. There are some subtleties of summing all of them together, which I will talk about in a separate video. But it will give us a kinetic theory, which is the distribution. Give us a distribution function, and from here to here, we'll wind up having a relatively similar answer, but with a distribution function. The F is a force. The S stands for species. And for the right hand side is a distribution change due to collision. So if the collision is not equal to 0, then it's a Boltzmann equation. If it's equal to 0, then it reduces to a velocity equation. So if we integrated the distribution function over velocity, we'll end up having a density distribution, which is distribution over space and time. That's the first moment. So, and also it can have an infinite amount of moment. By moment, I mean giving it multiplied by v to the n, to the nth power. And take nth, and it ended up keep going on the nth moment. So we have to find a way to have a closure. For me at least, the most commonly used for magnetized plasma is Brzezinski's equation, which you can find a lot of resources online. If we sum all the different species together, we think about there's only one fluid, then it will reduce to a magnetohydrodynamic model, which is consists of one fluid. In contrast to the fluid model, we will have ion and electron. MHD will consider all together as one fluid. It divided into two different categories: ideal MHD and resistive MHD. Ideal MHD will be is perfectly conductive, and the resistive MHD, as it sounds like, there's finite conductivity. There's a finite conductivity.